What's up, gamers? It's your boy Cody Fields from the Genesis Lab. I am super excited to be bringing you this presentation today on the introduction to TinkerCad. You might be thinking, what is TinkerCad? What is CAD? What does that mean? What is 3D printing? What is going on? Well, I'm going to be answering all of those questions for you in this presentation, and I'm super excited to have you here. All right, let's go over an overview of what we're going to be seeing today. First of all, I'm going to talk a little bit about what the Genesis Lab is. Maybe you've never heard of it, maybe you've heard some things, but you're not exactly sure what we do, why we exist. So I'll clear that up a little bit. Then we're going to get into some basics of 3D printing, some of the rules, how to think about 3D printing. We're going to play a fun little game that I like to call Print or No Print. This is based off of Howie Mandel's Deal or No Deal. But I changed the rules a lot. But it's my hot take. So, anyways, and then we're going to be going on to some basic controls for TinkerCAD. How do you maneuver around? And I will be showing you that in part on the PowerPoint, but then also going over to the actual TinkerCAD website and showing you how that works. And then lastly, I'm going to leave you with a design challenge. I'm just going to post up a bunch of different things that have been designed before on TinkerCAD. And I'm going to tell you to go make something. And I believe that you should be able to do it. All right, let's jump in. What is the Genesis Lab? Well, we are a group of people dedicated to the belief that Pepperdine's community is full of bright minds. We know that the students at Pepperdine will have great ideas. We have a lot of business majors here, but even people who aren't business majors, art, math, science, English, people create some beautiful things, and we know that Pepperdine is going to have people that are going far. And so we want to give as many resources as possible to the Pepperdine community. And so that is why we are a makerspace. We are the makerspace at Pepperdine. We have stuff like virtual reality. We got stuff like 3D printing. We can even make t-shirts for you if you want. So a bunch of resources and a super cool program designed specifically to help people make what they want to make, right? And so that's why we're called a makerspace. So that is the Genesis Lab. We are free to use all the time, right? Or not all the time, I guess, but we are completely free year-round. You can just come in, you can drop in. We're on the second floor of the library. Feel free to stop by just to say hi, or if you want to make some stuff, then we are totally cool to help you out. So don't be afraid, don't be shy, come on in. All right, so let's get into some actual 3D printing. What is 3D printing? What is it used for? You know, is it really just like a hobby that people have? Well, yes and no. It actually has a lot of really cool uses. One of them is space exploration. So they have a few 3D printers up in the ISS, that is the International Space Station, and people will often, the astronauts may lose a wrench in outer space or something, and rather than spend millions of dollars to have a rocket fly up a new wrench, why not just print out a new one, right? That sounds so much easier. Let's just 3D print out a new wrench. And so they use that for different purposes up on the ISS, but super useful thing. And then someone said, well, wait a minute, why don't we take that even further? And why don't we send a 3D printer to Mars? And so people want to send 3D printers to Mars to print out the structures that astronauts will be using when they get to Mars, right? Isn't that incredible? So that they get there and then they already have their home built for them, so they don't have as much work to do. They don't need to be doing all this construction, and they can be safe on Mars. And so that's a pretty neat application of 3D printing. You also see 3D printing in medical practice. It's becoming more and more common to see prosthetics that are printed out 3D printing wise. In fact, it's not just like the prosthetics that we see on the outside. Sometimes people can even print out 3D printed heart valves. That has been done on several occasions. You can design a heart valve on a CAD like the one that we're going to be using today, and you can print that out and use it for an actual person in surgery. And so that has had major medical implications and has helped a lot in the scientific field. And then lastly, what you're probably here for is creativity, right? 3D printing is a really fun thing to do. You can make a lot of really neat things for personal use. You know, I've used it to make trophies or for giveaways for my club. So there's a bunch of different things that you can do with it, and it's a super fun way to get creative and make some new stuff. So you may be thinking, all right, well, what is it exactly that goes into a 3D print? And there are different materials that are used. We call them filaments. The most typical kinds are plastics. Um, right, so that's stuff like PLA, ABS. You don't need to like memorize these, but you know, if you're thinking, man, like I have a 3D printer, or like I want to know like what is needed to print stuff. These are the typical kinds that are used: PLA, ABS. It's just a plastic. What happens is that a nozzle heats it really hot, so it becomes liquidy, and then they kind of layer it on to make the structure that you want to make. There's also flexibles, which are exactly what they sound like: flexible materials, kind of rubbery almost, like TPE, TPU. So those have their uses. Like if you want to maybe print out like a little toy car, you can make like an actual tire that has a rubber type property. There are also different types of infusions of filaments. There's wood infused, metal infused. The Genesis Lab actually has a wood infused baby Groot, and that one's a really fun one to use, uh, just for different designs. It looks like wood when you print it out. And then lastly, polycarbonate. That's kind of on the more expensive side of printing materials, but it's super strong. That's probably what NASA is using. I don't know for sure, but if I had to guess, that's the one that they're using, because it's this super durable material, great under a lot of heat, just overall very versatile. So yeah, those are just some different things that they'll print with. In the Genesis Lab, we tend to use PLA just because, cheap, it's recyclable, and it's just convenient to have. It's pretty much accessible, and it's very easily accessible all across the interwebs. So, all right, let's get into some basics of what 3D printing is, how it works, how you should be thinking about it. So there are a few design rules. For one, you want to think from the bottom up. I've attached this meme courtesy of iFunny. Right, so they say it's a mystery how the pyramids were built, but I reckon they started on the bottom, worked their way up, right? Because let's face it, it looks a lot more difficult to start from the top and work your way down, right? Gravity is a thing that exists, and we can't ignore it. So we need to be starting at the bottom. We need to have a really strong foundation, and then work our way up for our designs. Number two, stay in the grid. You'll see in a second with this interface that there is a grid work plane. It's like in the format of a grid, kind of like a graph or something. And you want to stay within that as much as possible, because your 3D printer does have limitations of how far it can reach. And you don't want to go outside those limitations, otherwise you may end up with filament all over your floor, or you may end up with just a mess, a failed print. So you want to stay in the grid as much as possible. Third, simple is successful, right? There are a bunch of simple shapes programmed into TinkerCad already for you to use, so you can kind of combine things and do as you wish. But you don't want to get too complicated. You really don't. As great as 3D printing is, and as fun as the designs can get, you want to keep it relatively simple, because your printer, right, like I said, it's layer by layer. And so if you make that design too complicated, it's not going to know what to do, and you're going to get a mess of a print, and nobody's going to be happy, because now you have a failed print and you probably have to clean it up, and you just spent who knows how long printing this thing. So try to keep it simple as much as possible. And then number 4, we're going to use something called supports for extrusions. Remember how I said we're going to think from the bottom up, right? Well, what about if we have something sticking out? Like maybe we want to print like a lamp post for like a little model town that we're making, right? Well, what if I want to do that? Well, the answer is that you use this thing called supports. And in TinkerCad, there's actually a button that automatically says generate supports when you're about to go print it. If you're sending a print into the Genesis Lab, we will probably know when to add supports for you, and we can do that for you without any trouble. So supports are necessary sometimes, because you want to have, right, you want to be able to build things that are like kind of sticking out and maybe just don't look like a pyramid. So that's just important to remember. All right, let's jump into this game. Print or no print. Right, so the rules of this game are pretty simple. I'm just going to put up a model of something that somebody was going to 3D print, and you are going to guess whether it got printed or not, and not as in like, You know, did it get put on the queue and like we went to print it? But like if it actually like was a finished print and if it turned out okay. All right, so let's go ahead and start. We have this blue coin, and it has like a water droplet on it, and it's about 1 millimeter thick. So take a guess. What do you think? Look at it. All right, got an idea? Yeah, so this is printable. So this is I say go for the print, because right, if you think from the bottom up, all those walls are supported underneath. We don't have anything like hovering or whatever. And it's also, you'll notice, I put in this measurement of 1 millimeter. Uh, so that's just to show, right, those little details about like the curves of the water droplet in the middle there and that little like indent that's in there. Those are all going to be covered, no problem, because it's not too detailed relative to the size. All right, next. This is a model of the Drescher Graduate School Apartments. So print or no print? A little more tricky, right? Might be thinking about those windows. Are those windows okay to print? Or those doors? Can it hold up by itself? Think you got an answer? All right, well, the answer is print. These actually were printed, and these were used in a demonstration when discussing remodeling Drescher and remodeling the apartments to see how the room orientation should be displayed. And this did print okay. It needed supports for those windows, so if you were concerned about the windows, that was good intuition. This needed supports in order to be printed, and it's nice and easy. You can just go in and you can cut those supports out of the windows, and you're pretty much left with exactly what you wanted. So this is definitely printable. All right, next, print or no print? Now you might be looking at these objects and thinking, yeah, that's a printable. Like I don't see any problem with that. You know, maybe this object here on the right is a little bit funky with how it's overhanging, but you know, maybe that could be fixed with supports. Um, but unfortunately, this would not print, and it's for one simple reason, and that's the fact that these objects are each maybe 1 or 2 millimeters thick. Right, so these are tiny little things, and your 3D printer likely does not have the capability to make design this like minuscule, right? It's not going to be that detailed. You know, some people have super detailed 3D printers that can do stuff like this, but odds are this isn't going to print, so it's a no-go. An easy way that this can be fixed is by just scaling the size up. Hopefully it's not one of those things where it's like you need it to be too small. All right, going on. Print or no print? This is a pumpkin design contest. This was for a Halloween contest last year. I actually made this one, and so maybe this reflects on how good or poor my designing skills were. But this was also when I was just starting to learn how to tinker. So, all right, got an idea? So this sort of printed. Right, you may be thinking, well, there's kind of a lot of overhang here with this whole pumpkin structure going on. It's kind of like a weird looking design. Well, incidentally, the pumpkin structure was fine. That could be held up by those supports. There were a lot of them. I spent about 30 minutes cutting off those supports. Usually it takes about 15 seconds. So there were definitely a lot of supports that I needed to cut off and get those details out of. The issue, however, wasn't with the overall design. It was with this little part in the middle here that says best design. That was a problem because it was too detailed. And so the supports actually ended up getting stuck in there. And when I was trying to cut them off, they would clip off some of the parts of the letters, and some of the filament would get stuck in between the two words. And so that ended up being a little bit of a mess. But overall, it turned out to be an okay design. All right, next. Print or no print? Right, okay. I hope you said no print. immediately, because this is kind of ridiculous. I'm not gonna lie. Like, we got Bumblebee here. Like, Transformers are cool and all, but this is just, you cannot print this. Even those super detailed printers are likely going to have a really tough time trying to get this done. There's some printers where you can actually, like, they're in this kind of gel and they don't even need supports, and it just prints into this like space. But those cost like thousands of dollars, and like, or thousands more than regular printers do. And so just this is not going to happen. No matter how big you make it, it's just way too detailed. The structure is way too complicated. That's not going to happen. Okay, let's get into some controls a little bit about how to run TinkerCAD, how it works. So if you have a mouse pad, like most MacBook laptops do, um, then right clicking is your selection tool. That'll allow you to kind of just you can select multiple things. You can click and drag something over. Um, right, it's just pretty basic selection tool. Control click allows you to rotate your view. I'll show you what that means in a second. And then control shift click means you drag, right? So you can drag your plane around. I want to note for people who have a Mac that you do still use the control button for the Mac. You don't use the command button. I know it's a little funky having both of those, but the control button is the one that you want to go for. So don't get it mixed up. It's just control, just the control, and then control shift as well. So if you have an actual mouse, you get all of the same features as with the mouse pad, but now you have a mouse wheel, right, for scrolling. So if you click down on the mouse wheel, then that allows you to drag it around, which is the same as doing control shift click. Or if you scroll up and down, that allows you to zoom in and out. Isn't that nice? So yeah, that's great. Okay, so next, this is what your interface is going to look like for TinkerCAD. Right, you notice there's that grid I was talking about earlier, what it looks like. So I'll just go through here from the top and I'll work my way down. So up here in the top left, that is a perspective box, right? So basically you can click and drag it around, and it's like rotating the view so that you can see what you're looking at. That is basically the same effect of control click, if you're doing it with the mouse controls. But if you're too lazy to memorize that control, then that box is right there for you in the corner, so you can have that. The home button returns you to the front so that you can just see your print from the front. You see the entire thing, the entire work plane, just so that you can kind of reorient yourself. Optimal view is if you have an object selected and you just want to kind of focus in on that one object. What you do is you can press the optimal view and it'll make that kind of like the main object in your window, and like the other stuff that's around it won't be as in the way. Zoom, I'm not going to insult your intelligence with what that does. And then this last one, switch to flat view. So that's kind of an interesting button. I personally don't love it, but basically it kind of changes the perspective so that you can see it from like an angle, and like a one fixed angle versus like a 3D perspective. And some people like it for measuring stuff out. Like it gives them comfort to have that, but I personally am not a fan of it. If you want to, you can play around just clicking back and forth between those two. And then you'll notice, right, the snap grid at the bottom right there. It says it's adjusted to 1 millimeter length. So that means all of these tiny little squares that you see here are 1 millimeter. That's super useful for if you want to measure out stuff. If you want to know an exact measurement of, say, a screwdriver or, a wrench, or even just like if you're trying to make something and you want two pieces to fit together well, you can come down to the millimeter and measure that accurately. You can also, if you're not familiar or comfortable with the metric system, you can change that to inches by going to the edit grid button just above it. Okay, lastly, for controls, adjusting objects, right? So remember this: squares adjust size and arrows adjust orientation. And I'll show you a little bit what that looks like, but these are the symbols that you'll be seeing And just remember, when in doubt, squares adjust size, arrows adjust orientation. And also, these are not the only two arrow symbols. There's also one other one that you need to remember, and that is your mouse. Your mouse is an arrow, it's pointing. Um, and that allows you to drag and move your object around. And so arrows are adjusting orientation or location. And then those squares adjust size. And I'll show you right now what that looks like. So here we have an empty work plane. You can see it's already at the front view, and you can kind of move that around, or right, like see the perspective there. So I'm gonna go ahead, and for the spooky season, I'm gonna look for a pumpkin. I believe it is under the characters menu. Oh, they have a jack-o'-lantern. Even better. Great. So we're gonna put in a jack-o'-lantern. So you can see our jack-o'-lantern is now here on the screen. Now this is great because as you you can select it and view it, and we can view it in all these different angles. And if you select the object, you can see these squares and triangles that appeared, right? So right, the squares, if you want to make it longer, you know, if you want to really just long jack-o'-lantern for some reason, you can do that by dragging those. The white squares are on the diagonals. The black squares just adjust one dimension. And then you can also use that white square at the top to adjust the height. So if you want to make it like a taller pumpkin, you can do that. And then, as I said, arrows adjust the location and orientation. So your mouse you can use to drag it around. This arrow at the side here, these little like double arrow looking things, those will adjust the like how much it's rotated by. And then at the top, you can see this little cone type arrow sticking up. That actually allows you to lift up from the bottom. So you can see, I'll go ahead and return to the front view here. So you can see it's lifting up from the bottom, right? Isn't that cool? So if you want to say put like something else underneath this, like maybe I'm gonna go back to basic shapes here. Maybe you just want to put a box underneath it, you know, to have your pumpkin up on a box. Then you can click this arrow, you drag it up, and now your pumpkin is sitting on this box. So great, cool. Another thing that's awesome that you should know about is that you can merge these two objects, right? So now we have this pumpkin in this box here. And what if I just want to keep these as one object so that I don't have to try to scale both and guess how much I need to scale each one by? Well, there's this little convenient merge button or group button. And you can press that, or you can do Control G, and you'll notice when that happens that it should become monochromatic. It doesn't always, but basically these are now one object, and if you adjust them, if you adjust the size of any of the dimensions, the entire object gets adjusted. And so that's really convenient, great for scaling stuff, and good to know about. And then you'll also notice a little box pops up anytime you select an object, and it gives you two options: solid and whole. You might be thinking, what do you mean whole? How do I print that? And the answer is you don't print a whole. But if you add in an object, say like a sphere, what you can do is you can make that object a whole and merge those objects together. And what that does is it basically puts a hole in your object the size that you wanted it to. So I'm trying to move around and show you a little bit here what that looks like. So that's a super convenient thing to have. And there's a lot of different uses for that. You'll notice that there are plenty of basic shapes that you can use to get started. Some of them even let you draw, so you can create your own. But also this menu over here, it has a drop down, and there's a bunch of different things that you can choose from. So don't be afraid to check out that menu and see what's there. Okay, that'll be all for the instructions on how to get started. This is an introductory course, like I said. There are some more advanced things that you can do with work planes and making sure things line up nicely with your rulers. But maybe that's for a later, more intermediate level class on TinkerCad. So I'm going to leave you at the end here with a challenge, right? I'm just going to go ahead and put this up. this is for you to consider. Um, right, there are plenty of different objects that you can build if you're not sure what you want to do. Maybe you're inspired to go build something, and if so, then go do that. But if you're not sure, but you still want to get some practice, here's a list of some things that people have built in TinkerCad before. Some of these are trickier than others, I'll be honest. The carabiner is a little bit on the tricky side. The catapult, you have to kind of know what you're doing a little bit. You really got to have perspective as far as knowing how to add in the hole for an object. Um, soda can covers, whistles, those are all pretty basic. So don't be afraid to try one of these things, and I wish you the best of luck. And if you want any help, don't be afraid to reach out to the Genesis Lab. The student workers are here, and we are definitely available to help you if you just have any questions about 3D printing in general. And also, don't forget that if you want to 3D print for a class, right? So say you have an art class coming up or a science project and you need a 3D print for it, you can email us and we will print that to you for free and we will mail it to you. So don't be afraid to reach out to us about those kinds of things. All right, I'm going to go ahead and wrap up there. Thank you so much for joining me on my introduction to TinkerCad. This has been Cody Fields. I really appreciate you listening in, and I hope you found this informative. Take it easy.